Hi guys, nice to have you back in this lesson here, where we want to work now with our blockout of our lid of our coffee cup. One thing I've done between the lessons is that I went through this tree here and named my nodes. And also I selected two of these nodes here and colored them red again, because I think that these nodes are later typical nodes which I want to change. So let's analyze first my naming convention so that you can follow along if you don't use my Gumroad files. And then we talk about making here a drinking hole and also an indentation. So let's first go through that here. And I hold down the R key on my keyboard and I drag here again my display flag onto this here. I named this lid contact height because this was the side here. Then we had the lid inner, which made this little rounding here. Then we had the lid border, which brings the whole thing in. Then we had a ridge, which I generated here. And then we have the ridge width. And I think that a ridge width here would be cool that we can later change it. So if we look here to the final result and take here the ridge width again, you see if I change now the insert here, it moves all the stuff in and out. And I think this here is something really useful here later. If you want, and this is the big advantage in the procedural approach, is that we can later change here also the divisions to hold better in subdivision surfaces and also have more or less polygons here to your liking. Then we have here the ridge up, which brings the whole thing up here. And what I do here now is I go here to the cup, I hold down the E key to set the template flag here to the cup. You see that this is really flat at the moment, so maybe I go here to ridge up, change the distance so that it looks a little bit better here from the complete size, and then we can change here how it goes in, maybe something like that. And if you now have the feeling that you need a little bit more resolution, you can do it here. Then we have the top lid border, which is this area here. And yeah, I don't think that we have to change this. The polygon size is really equal, so nice one. And then we close the whole lid here with a lid close. And this is really important. So if we now press the plus key on our keyboard to take a look here now, it looks like this here. And I like the shape and the height of all of that. Yeah, maybe this is something we can now work with. And if you want, you can play now a little bit more with the height. Yeah, but this is a creative process, which you can do then later at home. What we now want to do is here the indentation. And if you take a look into our composite view, into our references, you see we have different kind of indentions. Here is one, and yeah, here is a small one which is equal, and here is, yeah, like a hole here. So maybe something like that here. Let's play with that. So let's go back to the scene view. I switch here to the object view again, dive into that, and I go over the viewport, click in it, Shift minus to remove the subdivision surface display here. And now think about how to make the indentation. We will, or we can use here polygon selections, and we can extrude them and move them like we've done before, but then we are a little bit more limited in our procedural approach. And so I decided that I want to use again Booleans, and we discussed Booleans in the lesson before this, so the same reasons are here. But what I want to make sure is that I always use the same amount of polygons for both Booleans so that I don't get problems in topology and that I always get here this procedural tree. I go here to lid close because here everything is finished, everything works. And I branch out from this here. If you now select this here and take a look here, you remember we used top all the time, and you maybe are thinking, yeah, this here is top and we can branch it out and delete everything. Try this and you will find a problem. So use a blast here, go in, top is still there. Yeah, but now if you delete non-selected, it seems that nothing works, or you can look here, something strange is going on. The problem is that top is always changed, and we use that all the time here, and now it's a disadvantage for us because top is now gone. It was there somewhere. Also, if you change now here and change the insert, top is not what we want. We need an area here in the middle. So top is not our friend anymore for this here. But what we now can do is we can make a selection. And we talked about hard selections in one of the earlier lessons of the CoffeeCup, where we went in here and selected primitives, made selections, used them. And you remember that every of these primitives has a number. And I said, yeah, this is a problem if you later change the divisions or something like that because the numbers change. So can we have a clever selection? Let's remember what we have learned in the earlier lessons. One way was we had a group node. And if you take a group node here, you remember we had this base group where we had numbers. If you deactivate this, I think I explained to you keep by normals. So if you enable this, we can have here direction, for example, everything looking into Y direction. I say direction X0, Y1, Z0. And then we remove the spread angle here. And if we do something like that, I go here to the handle tool, everything is selected, which is looking upwards. Great, but we also get that here. A little bit tricky at this point. Another idea would be include edges, and you see here you have edges which you can use here between angles. So this here is a really nice way of selecting, and I use it mostly for edges. So if you do something like that, you see you have now edges which you select between angles and so on. But one of the real power functions here inside of that, I think I can deactivate the numbers here, is bounding regions. So if you click that here, you have now different kind of bounding regions. There are built-ins, which are bounding box and sphere. And you also can deliver your own volumes, so object and volumes here through this second input. So if you now take a look here, see if the handle tool is active. Here is a box, and this is this bounding box here. So we can change this to a sphere, for example, because we need something round. And now we select everything which is inside of this sphere. The sphere doesn't sit where we want to have it because it's asking its position here from the center. So we have to move now this center here up where this here is. How to do now something like that? For this, we can use an expression, for example. You remember we used expressions in one of the lessons before, and let's try the following thing. What I want here is that I move here the Y to the bounding box maximum value of Y. So I go into this field, and you can type directly your expression into this field here. But what I do is I go in here, Control E for opening the expression editor. And the function I now use is bbox, which stands for bounding box. And if you open your bracket, you now see the documentation. The first thing, and this is the usage here, is the surface node. So which surface should this expression analyze? And what we enter here is a 0 because we want to analyze the first mesh which is in the stream, and the first in programming is 0. So we go in here and say 0, and then we have to type what we want to ask now, this function. And for this here, for the types, we have here different kind of types. You see d underscore xmen, d underscore ymen, and so on. So let's try this. We asked mesh number 0, and then we have to type what we want to have, and these are constants. So that's the reason why they are in big letters. So we ask for dimensions underscore y max. I close this and we apply, and now you see no error at all, and you see now our sphere sits exactly where we want to have it, at the top here of the bounding box. I hope you understand the idea behind the bounding box, and for the people who never heard about that, maybe it's a good time to show you a note for that. But you also find out about the bounding box if you hold down your middle mouse button here. You see here on the right, you see the center, and the minimum and maximum values. And you see here our friend 4.647 something. This is the maximum bounding box. So here you can read it. So this is the bounding box of this cup here, or everything which comes through that. And yeah, you also can output the bounding box as an object. And for this, we normally use the bound node. So the bound node, if I hook this up here, you see we get now exactly here the bounding box of W of our stream here, which is here at the top. And then we can tell how the bounding box looks, and we can add a little bit to the box. Sometimes you need a little bit more space or less space. So these are the paddings. So this is the bounding box, a box around the whole thing. If you take a look here, you see this is now templated. This is the bounding box of our lid. Okay, this only as an explanation. So we go now here back, we go into the group. We have now found out the top of our lid here and placed our bounding sphere here exactly here at the top, and it will always work. We don't want to select edges, we want to select primitives. That's important. Then we name this, for example, indentation area, so that other people will understand what's going on. And you also can use the name maybe here for the node itself, so that other people know that. And now we can size this box. We can do it here or here. And I know it's not a box, it's a sphere. So yeah, make it bigger. And this is the area where I want to have the indentation, for example. And what you can do, because this is something you maybe want to change, yeah, make it red again. Great. Done until this point. Now we need only half of this. So let's take a look how it looks. I need only this area here. So for this we use another new node, which is clip. And what clip does is it divides everything by an origin and a direction. So it's really like a knife. And what I can do now is, first I need to get rid of everything which is not in the indentation area. This is a fast thing. So blast away everything which is not indentation area. Here we go. Then we clip the whole thing. And the clip here is again, if you go here now to the handle tool, it starts here, the origin. So question, can I move this here exactly here to this point to have it more easy? You don't need it. It cuts the plane. So if you now bring it here, you see the plane always works, but maybe it looks nicer if it's placed here. So time for another channel expression. Let's get started. What we have to set is the origin here. So we use the bounding box, which is always the top and the bottom and the right side and the left side. But sometimes we ask for the center of something. And for this, we also have a function. Let's go here to first y, go in here. And the function for this is centroid. With centroid, you ask for a center. So open your brackets again, and we get an explanation again. Nice. We need a string again, so we ask again for the surface node, which is again 0. So the first mesh which comes in. And then we have to tell it here what we want. And what we want is, because we are in origin y, we ask for the y centroid, which is d underscore y. d underscore y. We close the whole thing, click apply, and now you see the whole thing here vanishes. Reason for that is that now the centroid sits here and we cut here now in one direction. You see, it has worked. Yeah, so the problem is now that we cut now exactly here on this. Was nice? How do we now center the rest here? It's enough to have this here, but maybe you want to also center the rest here. Same thing like before. So you can go in here and tell the system centroid. This time I do it here. Open it 0, point, this is x, so d underscore x, and then you press enter. And the same thing here, centroid 0, this is dz, and now we have the center of everything. And one thing which is asked in Houdini trainings all the time, if I make trainings for people, is these expressions here are really useful. Can I store them somehow, or can I store a node like this? Yes, you can. There are two different ways. If you, for example, say this clip here, which works from the centroid, so let's name it clip from centroid. You want to use it later, you can do one of two things. You can select now the node here and go here to this cogwheel, and here, if you look into that, you can save now a preset for this node here, and you can save it here. You can tell where in your system you want to save that, and then you have it next time here in this list, and you can use here a preset of that. Or another way of doing it, and this is really similar for people coming from Maya, is your own shelf. So you can click here to the plus sign and you can generate your own shelf. So make one. I make a new shelf here. I name this shelf, for example, pixeltrain, and this is the program name, so I don't use spaces here, but the label, yeah, you can use like you want. Okay, now I make one. This is an empty shelf. And then you can take a node like this, which is configured like you want it. I named it. Take it and drag your node here. And now you have here the node. You see it takes the name with it. And if you now, for example, delete that and you need a node like this, you can click here and then you can add the node here to your system. So here it is. And if you press the F key, here it is. So this is the node now which you can use. Another interesting thing is if you have a shelf and you save it and you restart it and you use the tab key and you now enter the name clip, you see here you have now a new tool in your list which is named clip from centroid. So you also can now use it from here because it's a part of the shelf, and so it's a part of your nodes which you have in your tab menu. Okay. That's enough about that. We use now here this clip from centroid, and you have seen that with here this moving of the clipping plane, you can move now the plane where you want to have the cut. Then we need a direction, and what I do now here is I hold down E key and make the cup again visible so that we see what's going on, or better, I want to have here the lid. It's more important for that. Then we take here the clip and we place it here, and then we need a direction, and I want to have here the Y. Now you can clip it here, and if you want to snap now, hold down the control key. Then you see you snap here. Okay. Now it's snapped. Now we can remove our distance. I only used it for helping you with these values. And now you can decide by moving it here around where exactly you want to have it. But in our case, yeah, we have to use here the distance because the origin here is fixed, which are these axes. So I have to move it here to the front or to the back if I want to change that. Okay, edit 0. 0 is good. And now we can make our next step here. We have now this area here. What we need for all the Boolean operations best is a volume, so that we have an inside which is then booled out here. So make a poly extrude here for that. Okay, here we go. If you want, you can have now divisions so that we have a nice topology again. And the whole thing is really important that you see that this topology fits exactly here the top. And then we take here our Boolean, which is a Boolean subtract. So it's pre-configured as a subtraction. We take this one here and this one here. And if we now take a look here, nothing happens and we get an error because this here sits too high. So if you go here, you see that this here is still here at the top. So I have to move it down, and for this we use a transform in this stream. Okay. And now, while transform is selected, now we see our transform widget is at the wrong place. Little trick here, name centroid again. You also can center your centroid here with a button in the transforms. So if you click here, move centroid to origin, you will see it looks a little bit counterproductive. It moves the mesh to the centroid. But if you then zero out here the translate, control middle mouse button click, you see now it's back where it belongs and the centroid is now really in the center of this here. Okay. And then I can move this down now into our mesh. Looks like that here. And now you see we lose here this part. And the question is, why do we lose that? If we take a look here into the Boolean, you see that it thinks that set A here, so our cup lid here, is a solid, which is a volume, and it isn't. So what you can do is you can tell it, okay, it's a surface. Then you get this here as a result, which is not exactly what you are after. And if you go here and say this is a surface, it doesn't work at all. So how do we fix now that? Because I need here this inner part. For this we can close this shape here for a moment. So let's take this shape first, which is open, and close it. And we can do it, for example, with a poly cap. So close it. Now it looks like that. And we get a simple polygon. We can say, show me the patch here. So this is the closing patch, and if you go here, see this is the patch. And we go back to the Boolean and test, and now you see that if we go here back to that here, that it should work. Let's take a look here. Doesn't seem to work. If it doesn't seem to work, sometimes it's also a question about if everything is closed. And now you see my problem. You see here, this here was open, not that. Okay. Sometimes it happens like that. I don't think that I have to cut it out because you have to learn exactly these things. So I go to the poly extrude here, which made this form here, and we go to output back and close it. So this is a closed shape now. Let's go back to the Boolean and first test if it now works like expected. Yeah, now it works. And now let's deactivate the polyfill for a moment, only to make sure that it works. Yeah, and now you see it still works because it's a really clever one. So we can get rid of polyfill here if we like. If you have to use polyfill and you later want to get rid of that, remember that there was a patch group, so we can blast it away later. And now we can change here the appearance of this area here. So what we can do here, for example, if you go back here to the poly extrude, which built this thing here, you can now go in here and say, yeah, I want to have it going a little bit in this direction. So let's take a look here. Now you see, you can start playing with that here if you like. So to have it a little bit more curved here, or you can really start doing other crazy stuff with that. So I don't do that now here because I think it's clear how it works. Here you have again your divisions. So to have a nice topology here on the side. And yeah, now we have our indentation here.